to start the Earth's History unit. Starting off with page 8 and 9 of your reference table. Please open up to that. That will help you out along with your notes. So on page 8 of your reference table, you will notice that there are 14 geological time periods that break up the history of the Earth. The most recent one, or the one at the top, all the way up here, because there's the period, sorry, there's epochs, the period's right there. The one all the way at the top, the one we live in, is called the Quaternary. And it extends down to 1.8 million years ago. So next to the epoch, you're going to see numbers. Those are in millions of years. This is going to be the time all the way down next to the life on Earth. So before the Quaternary, you can see right underneath it, you have the Neogene. Before that, you have the Paleogene. And then you have three that go together that are the Cretaceous, the Jurassic, and the Triassic. Those three right there, they're known as the dinosaur periods. That's where you find all the different dinosaurs. Before that, you have the Permian, and one that is split into two micro periods, but we're going to clump them together and use the term that is given for both of them. So we're going to call the Carboniferous, knowing that they have micro periods of the Mississippian and the Pennsylvanian inside of it. Then you have the Devonian, the Silurian, the Ordovician, and finally the Cambrian. But that's just 12. And I said earlier there are 14. So if you look around a little bit farther over to the left, you may find the last two. The last two are going to be under this one right here. It's going to be in the middle. You can tell that it's the periods because it has epochs next to it, like the earliest, middle, and last. That will be very, very helpful to you. You're going to notice right there, you've got the Proterozoic, and then the most earliest one is the Archean. All right, so now that we've seen all the periods, why don't we scooch over one to the left? And I did brief on epoch. Epochs, for the most, they tell you the earliest, the middle, and the last, except when you get into the Paleogene. Then you have the Pliocene, Eocene, Oligocene, Miocene, Pliocene, Pleistocene, and the Holocene. So all of those are epochs, but typically you're going to see early, middle, last. If we move over to left, so we went from epoch, period, and now we're going to look at the era. There are only three types of eras. You've got the Cenozoic, Mesozoic, and the Paleozoic. Those are the three eras. And if you pull them back, if you follow the lines and you pull it all the way back into the eon, this is going to be found in the Phanerozoic eon. So if you follow all of these back up, you're going to see they're going to be into this little tiny chunk called the Phanerozoic eon. And the other two periods, the ones that we talked about before, those are found right there in the Precambrian eon. Okay, so let's go to the bottom of the Archean period. And you're going to notice on the very left-hand side that there are numbers again. These are in millions of years. And all the way at the bottom where it estimates how old the Earth is, it says 4,600 million years old, or 4.6 billion years old. So when the Earth was really, really, really young, just started, it was basically a ball of lava. It was a whole bunch of molten rock with volcanoes going off everywhere. There's no life, no oxygen, no nothing except for lava. Water didn't arrive until they're theorizing asteroids hitting the Earth and meteorites hitting the Earth, and that brought water. And that was roughly about 3.8 billion years ago. It's not listed on here. However, you can infer that because you see that you've got oceanic oxygen. So there's got to be ocean, there's got to be water somewhere. And on this, in this little section right here, it tells you a little bit about the life on Earth. And in that, you see a little before, a little after 3000, about after the middle of the Archean, you're going to see the earliest stromatolites. So the stromatolites, they were the the life forms that gave us oxygen. They're also known as algae. And then after that, you have the cyanobacteria and whatnot. So about 3.5 billion years ago. So for the first 4 billion years of Earth's history, there was really no life on Earth, on the land at all. In the oceans, yeah, you had some in there during the Archean, like the late middle late Archean and the Proterozoic. And then right about there, 5.42 million years ago, right at that Cambrian boundary, life exploded. It came up in the ocean, and we finally have living things in the ocean. And life then finally comes up on land during the Silurian period, where you have earliest land plants and animals. And where I'm finding that is I'm finding life on Earth, and I see earliest land plants and animals, and that's in the late Silurian right there. All right. And so what I was just looking at is life on Earth. And right here is the life on Earth with the epochs and the periods. And what I'm going to look for right now is where can I find the earliest? Let's find the earliest of these different things. Fishes, insects, mammals, birds, flowering plants, and grasses. Well, let's look for fishes first. Fishes, like I said, ocean. Let's look towards the bottom. Well, towards the bottom, you're going to find earliest fishes all the way down here. It's going to be in the middle Cambrian. All right, what about insects? When did insects come up? I'm going to look for earliest insects in the life on Earth, and I find it in the late Silurian. All right, mammals. Mammals all the way up here in the late Triassic. Well, what about birds? Birds are even higher up in the late Jurassic. Flowering plants have to be before that. Nope, look, there's the flowering plants in the early Cretaceous. How about grass? Grass has to be there because we saw it in Jurassic Park. Nope, grass is all the way up here in the Oligocene and the Paleogene. Period. Kind of crazy, right? All right, well, another thing that life on Earth tells us or can give us information about is the two major mass extinctions that we have. So the first one that came about was about 251 million years ago. And you can see that by this little I don't know, backwards arrow things, captions. And it says that there was a mass extinction of many land and marine organisms, including trilobites. And this happened between the Triassic and the Permian boundary. And then the next one, if we go a little bit closer to us, is 65.5 million years ago, in between the Paleogene and Cretaceous. And that's where all the dinosaurs and the ammonids and a lot of land plants actually became extinct. And based on this is all this information you can gather just from this one side. We have a whole other side where you can start to see important geological events that have occurred, like the initial opening of the Atlantic Ocean, Pangea breaking up, and then you start to see the distribution of fossils. Right here you have the New York rock record. Then you can see the different parts of when Pangea started breaking up. All of this can be used by following straight across, all right? So if you have any questions, please don't hesitate to ask, and I hope you guys have a great day.